Okay, in this video, we're going to talk about Chapter 12, dealing with analysis of variance. In this video, we're going to talk about one-way ANOVA, and in the next video, which is Section 12-2, we're going to talk about two-way ANOVA. But in Section 12.1, which is one-way ANOVA, we're going to apply the method of one-way analysis of variance to conduct a hypothesis test of the equality of three or more population means. The focus of this session is the interpretation of the results from technology. We won't be doing any type of manual calculations here. Okay, so here we're going to introduce the method of one-way analysis of variance. And in short, it's ANOVA, A-N-O-V-A, ANOVA, short for analysis of variance. And this is used for tests of hypotheses that three or more populations have means that are all equal, as in this case, the null hypothesis would be mu sub 1 equal to mu sub 2 equaling to mu sub 3. Now, because calculations are very complicated, we emphasize the interpretation of results obtained by using technology. So you won't have to worry about doing any manual calculations because it is extremely complicated to do and time consuming, as I should say. Now, what we're going to be using for the analysis of variance, or ANOVA, would be the F distribution. That would be our test statistic for one-way ANOVA and two-way ANOVA. Okay, so the analysis of variance methods of this chapter require the F distribution. The F distribution has the following properties. Okay, so I can just bring this up a bit. All right, there is a different F distribution for each different pair of degrees of freedom for numerator and denominator. And the properties here are this. Number one, the F distribution is not symmetric. It is skewed to the right, as you can see in this diagram here, or in this graph. That is the F distribution. You can see it's not symmetric as the normal distribution and also the T distribution. The values of F cannot be negative. So here, this starts at 0, goes all the way out to just positive numbers. We have non-negative numbers only. The exact shape of the F distribution depends on the two different degrees of freedom. Okay. All right, so here the value of F, here they're using the square of the standard deviation of the larger number and the square of the standard deviation of the smaller. That's S2 squared. S1 is the larger of the two standard deviations. Okay. All right, so here's a definition of one-way analysis, or in short, ANOVA. Okay, that is a method of testing the equality of three or more population means by analyzing sample variances. One-way analysis of variance is used with data categorized with one factor or treatment. So there is one characteristic used to separate the sample data into different categories. Okay. Now, here are the key elements here for one-way analysis with three or more population means. Okay. Now, in this case here, we have requirements here. Number one, the populations have distributions that are approximately normal. Now, this is a loose requirement because the method works well unless a population has a distribution that's very far from normal. And then number two, the populations have the same variance, which is sigma squared, or the standard deviation, which is sigma. Again, this is also a loose requirement because the method works unless the population variances differ by large amounts. And of course, the samples are simple random samples of quantitative data. Number 4, the samples are independent of each other. That means that the samples are not matched or paired in any way. And then number 5, the different samples are from populations that are categorized in only one way. And you'll see something like that shortly. All right, the procedure, we're basically going to be using technology to obtain results that include the test statistic and the p-value. Okay, I'm going to show you how to use Statistic, because if you're doing your Statistic assignment, you have to have Statistic or signed up to Statistic, and it is online, so you don't have to download it on your computer. You can just go to statistic.com and do the get the results there. Number 2, you're going to identify the p-value from the display. The ANOVA test is a right-tailed test because only large values of the test statistic cause us to reject equality of the population means. Then you're going to form a conclusion based on these criteria that use a significance level. And it's going to be alpha. Now, you're either going to reject the null or fail to reject the null. To reject the null, your p-value must be less than or equal to alpha. Or if the p-value is greater than alpha, then you fail. You fail to reject the null hypothesis. Okay? So in this case here, when you reject the null hypothesis, you're rejecting that for equal means and conclude that at least one of the population means is different from the others. But if you fail to reject the null hypothesis, then you're saying that, well, you can't pretty much say anything. You're just failing to reject the null hypothesis of equal means. Just saying that there's not sufficient evidence. Okay? Because the calculations required for one-way analysis of variance are messy, we recommend using technology with this study strategy. Understand that a small p-value such as 0.05 or less leads to rejection of the null hypothesis of equal means. So we pretty much use the phrase that if the p is low, the null must go. With a large p-value, such as being greater than 0.05, you fail to reject the null hypothesis of equal means. And then number 2, develop an understanding of the underlying rationale by studying the examples in this section. So basically, we're just going to look at a few examples. And we do have some displays of outputs, and you'll just go through the 8-step procedure, okay? And it should be easy because in this case, you won't have to do any manual calculations or enter the raw data into Statistic or in the TI-83 or 84 plus calculator to get your output. It's already there in these first 3 examples, actually 4. All right, like in example 1. In a test of weight loss programs, 204 subjects were divided such that 34 subjects followed each of 6 diets. Each was weighed a year after starting the diet, and the results are in the ANOVA table below. Use a 0.025 significance level to test the claim that the mean weight loss is the same for the different diets. Okay. And this is the output that we have right here. Okay. I'm just going to go through the 8-step procedure with you all, just so you can see how this works. Starting with step number 1, and that's the original claim in symbolic form. And that's, of course, the claim was that the mean weight loss is the same for the different diets. And here in this case, there are 6 different diets here. So the way we write this original claim is going to be this. And we're dealing with means here because it says mean weight. So we have to use the Greek letter mu. And we're going to do mu sub 1 for the first. That's equal to mu sub 2, which is the second, equaling to mu sub 3, that's the third. Mu sub 4 is the fourth. Mu sub 5, the fifth, and equaling to mu sub 6. So that's how we write that original claim in symbolic form. Now, step number 2 is the opposite of the original claim. This is going to be different how we write the opposite of the original claim. We can't say mu sub 1 is not equal to mu sub 2, not equal to mu sub 3, and so on, because that would be too extreme of a opposite of the original claim. We only want at least one of the means to be different. So the way we write that, we have to just write it in words, saying at least one of the means is different. Okay, so only at least one. And in this case, it doesn't tell us, we're not going to find out which one is going to be different, which one of the 6 is different. It's just at least one can be different. That would be the opposite of the original claim. And this is step number 2. And then step number 3 is right now null and alternative hypothesis. Now, in this case, the null hypothesis always has an equal to in it. So in that original claim, all we have there is equal signs. So we'll write that. mu1 is equal to mu2, equaling to mu3, equaling to mu4, equaling to mu5, and equaling to mu6. That is your claim. The alternative, of course, is that statement that I wrote, where at least one of the means is different. At least one of the means. Okay. So that's step number 3. Right now, null and alternative hypothesis. Now, step number 4 is the level of significance. You're told to use a 0.025 level of significance. So alpha is 0.025. And that's to test this claim. Step number 5 is calculating the test statistic. In this case, our test statistic is our F value, the F test statistic. Looking at this output, here's our F test statistic right here. And that is 3.1082. Do not get this confused with this. That's the critical value for F. This is our test statistic for F, 3.1082. And then step number 6 is finding the p-value, where the p-value is given to you in that output. Here's your p-value right here. Now let's say I want to round that off to 3 decimal places. That would be 0.010. Okay, 0.010. And then I'm going to compare the p-value with my significance level, which is step number 7. And that decision rule is this: if the p-value is less than or equal to alpha, you want to reject the null hypothesis. And your p-value is 0.010. The alpha level is 0.025. compare these two, you're going to see 0.010 is less than 0.025. It's definitely less than. So that means it does satisfy the decision rule. That means you want to reject the null hypothesis. And then step number 8 is to write our conclusion. And pretty much the conclusion is going to be that there is sufficient evidence to reject the claim. Because we're rejecting the null hypothesis, that null hypothesis is your claim. So we're rejecting the null hypothesis, meaning there is sufficient evidence to, I'm going to say, warrant rejection of the claim. W-A-R-A-N-T, W-A-R-A-N-T, to warrant rejection of the claim. That the mean weight loss is the same for the different diets. Okay. Okay. So in this case here, we can reject the null hypothesis because our p-value is less than the level of significance. Here, our p-value is less than that level of significance of 0.025. Okay. All right, example 2. Is this. Samples of pages were randomly selected from 3 different novels. The Flesh reading ease scores were obtained from each page, and the TI-8384 plus calculator results from analysis of variance are given below. Use a 0.01 significance level to test the claim that the 3 books have the same mean Flesh reading ease score. And what will be the conclusion for this hypothesis test? Okay, so here's our output right here, as you can see. But let's just go through the 8-step procedure for hypothesis testing. Okay, so starting with step number 1 is the original claim. And in this case, we're testing the claim that the 3 books have the same mean. That means mu sub 1 equals mu sub 2 and equals to mu sub 3. That's how we write that. And now step number 2 is the opposite of the original claim. Just like we did in example 1, the opposite of the original claim, I'll just have to write this out in words saying that at least one of the means, we don't know which one, at least one of the means is different. All right, that's the opposite of the original claim. All right, step number 3 is writing our null and alternative hypothesis. Well, of course, the original claim has the equal sign in it, so that has to be the null hypothesis. Mu1 equals mu2 equals mu3. And this, of course, is your claim. And the statement, at least one of the means is different, is your alternative hypothesis. Okay, so that's step number 3. And then step number 4 is your level of significance. We're using a 0.01 significance level. So step number 4, we just write alpha is equal to 0.01. And then step 5 would be the test statistic. In this case here, we can look at this output and get our test statistic. Test statistic right here, where you have that capital letter F, that's your test statistic. Let's say I want to round that off to 3 decimal places. So this will be 9.155. 9.155. That's the test statistic. Now, step number 6 is your p-value. We can get that from this display right here. Notice what your p-value reads. It's got 6.338 and so on times, and then you got e to the negative 4. If you recall, this is scientific notation. That's this value times 10 to the negative 4. Okay? So in this case here, I need to move this decimal point 4 places to the left because it's a negative 4. So I only get room for 1 place to put the decimal point in front of this 6. I need to move it 3 more places. So to do that, I'm going to need 1, 2, 3 zeros. And then I can write the remaining numbers. 6, 3, 3, 8, 4, 8, 5, 4, 2, 2. Then I'm going to round that off to 3 decimal places. So this is the third number after the decimal point. The 6 will make this 0 a 1. So I'm going to have 0.001. That's your p-value. Step number 7. Is our decision rule, and that's this. If the p-value is less than or equal to alpha, we're going to reject the null hypothesis. This p-value, of course, is 0.001, and my level of significance is 0.01 from step number 4. In this case here, that 0.001 is, of course, less than 0.01. Satisfies the decision rules, and that means I need to reject the null hypothesis. And then step number 8 is going to be the concluding statement. We rejected the null, and the claim was the null hypothesis. So that means we have sufficient evidence to reject the claim. So we can write this out as there is sufficient evidence to warrant rejection of the claim that the 3 books have the same mean reading, well, the same mean, and I'll just name the same mean flesh reading ease scores. Okay. Oh, and by the way, for that p-value, if you didn't understand how I got that, I'll show you. That's what this means. 10 to this times 10 to the negative 4. The negative 4 in the power of 10 tells me I need to move this decimal point 1, 2, 3, 4 places, which means I need 3 zeros here. So this is what that is. Okay. Let's look at example 3. A sample of colored candies was obtained to determine the weights of different colors. The ANOVA table is shown below. It is known that the population distributions are approximately normal and the variances do not differ greatly. Use a 0.025 significance level to test the claim that the mean weight of different colored candies is the same. If the candy maker wants the different colored populations to have the same mean weight, do these results suggest that the company has a problem requiring corrective action? Okay, so there's our output from the ANOVA table. And it says here, should the null hypothesis that all the colors have the same mean weight be rejected? And does the company have a problem requiring corrective action? Okay, now I'm going to go through that 8-step procedure. And then step number 1 is the original claim. Okay. Now the question is, how many means do I need? Do I need 3? Do I need 4? Do I need 5? Well, let's look at this right here under DF. That's degrees of freedom. And in this case, the degrees of freedom is 7. And I know this, when you're finding the degrees of freedom, that's going to be 1 less than the sample size. So if I know the degrees of freedom is 7, that's going to be 7 is equal to n minus 1. And I have to think of this. What number minus 1 gives me 7? Has to be 8. So in this case here, I'm going to need 8 means that are going to be equal in my original claim. So my original claim, when I write this out, it would be this. mu1 equals mu2 equals mu3 equals mu4 equals mu5 equals mu6 equals mu7 equaling to mu8. So all 8 means have to be equal to each other. That's the original claim in this case. And now step 2 is the opposite of the original claim. So like in examples 1 and 2, the way I'm going to write the opposite is just going to be as a statement. At least one of the means, is different. And then step 3 is going to be stating the null and the alternative hypothesis. Well, the original claim is going to be your null hypothesis because all we see there is just equal signs in it. So mu1 equals mu2 equals mu3 equals mu4 equals mu5 equals mu6 equals mu7 equaling to mu8. That is your claim. And the alternative hypothesis is the opposite of that claim. At least one of the means is different. And then step number 4 is your level of significance. You're told to use a 0.025 level of significance that's given in the problem. All right, now step number 5 is the test statistic, which we use F as our test statistic in this case, since we're dealing with a one-way ANOVA. If you look at your table, here's your test statistic right there. Your F test statistic is 0.5554. So that's step 5. And then step number 6 is your p-value. Here it is right here. Your p-value is given there directly, 0.7894. And then step number 7 is our decision rule. If the p-value is less than or equal to alpha, you're going to reject the null hypothesis. And in this case, our p-value was 0.7894. And the alpha level is 0.025. Well, if you compare those two, you can see that 0.7894 obviously is greater than 0.025. In this case here, we violated our decision rules. That means we need to fail to reject the null hypothesis. So if we fail to reject the null hypothesis, and our claim is that null hypothesis, that definitely means that there's not sufficient evidence to reject the claim. Okay, so our conclusion statement would be that there is not sufficient evidence to warrant rejection of the claim that the mean weight of different colored candies is the same. Okay. So that's the 8-step procedure there. Okay, now I think they have questions here like, should the null hypothesis that all colors have the same mean weight be rejected? And the answer there will be no. Because notice our p-value is greater than the level of significance is very high here. Keep in mind the p-value is the probability of getting a test statistic that is extreme as the one that we got from the sample data. So we're talking about a 78.94% chance of getting a test statistic that is extreme as the one that we got for the sample statistics. Yeah. So that means we need to fail to reject the null hypothesis. And does the company have a problem requiring corrective action? And the answer there will be no. Because in this case, it's not likely that the candies do not have mean equal weights. Not likely that those candies do not have equal mean weights. All right, example 4 looks like this. If we use the amounts in millions of dollars grossed by movies in the categories with PG, PG-13, and R ratings, okay, Here we got a single factor, which is movies, and they're going to be in 3 categories: PG, PG-13, and R ratings. Now, in this case, we obtained SPSS analysis of variance results shown below. And this is what the output looks like. Here we're going to use a 0.05 significance level to test the claim that PG movies, PG-13 movies, and R movies have the same mean gross amount. And we want to find out what will be the conclusion for this hypothesis test. Okay. Here we do that 8-step procedure. Now we're dealing with movies in 3 categories: PG, PG-13, and R. So in step number 1, we have the original claim in symbolic form. We're dealing with mean, so it'll be mu1 equaling to mu2 equaling to mu3. Mu1 would be the mean of the PG movies. Mu2 is the mean of the PG-13 movies, and mu sub 3 would be the mean of the R-rated movies. Now, step number 2 is the opposite of the original claim. And in this case, the opposite would be this: at least one of the means is different. Because they don't all have to be different. We just only want one of the means to be different. That's enough for the opposite of the original claim. And then step number 3 is writing the null and the alternative hypothesis. Of course, that original claim all just has only equal signs, so that has to be your null hypothesis. Mu sub 1 equals to mu sub 2 equals to mu sub 3. That is your claim. And then the alternative, of course, is that opposite. At least one of the means is different. And now step number 4 is your level of significance. In this case, your alpha level is 0.05 this time. And then step 5 is your test statistic. That's the F. And it's given to you in this output. In this case, 3.704. That's your F test statistic. Now, step number 6 is your level of significance. Or, no, not level of significance, the p-value. Now, SPSS uses SIG, S-I-G. That's actually your p-value, to be exact. And in this case, it's going to be 0.035. Okay. That's your level of significance, 0.035. All right, and now step 7 is the decision rule. And that would be this: if the p-value is less than or equal to alpha, you're going to reject the null hypothesis. Otherwise, fail to reject the null hypothesis. Well, that p-value is 0.035. Your alpha level is 0.05. If you compare those, you'll see 0.035 is less than 0.05. It does satisfy the decision rule, so that means we're going to reject the null hypothesis. And then step number 8 is writing the conclusion statement. Okay, using simple non-technical terms. We rejected the null and the claim was a null, so that means we can say that there is sufficient evidence to reject the claim. So here we'll say there is sufficient evidence to warrant rejection of the claim that PG movies, PG 13 movies, and R movies have the same mean gross amount. Okay. Okay. So that's how we do that hypothesis testing procedure with using the one-way ANOVA. Okay. Finally, example 5 says this: the data found below measures the amounts of greenhouse gas emissions from 3 types of vehicles. The measures are in tons per year expressed as CO2 equivalents. Use a 0.025 significance level to test the claim that the different types of vehicles have the same mean amount of greenhouse gas emissions. Based on the results, does the type of vehicle appear to affect the amount of greenhouse gas emissions? Okay, so now we got the raw data here. Okay, I'm going to show you 2 ways of doing this. One is by using Statistic. The other one is by use of the TI-84 plus calculator, which I will be using. Okay, I think it's also on the TI-83 as well. Okay, but let's do our 8-step procedure here. Step number 1 is the original claim in symbolic form. Okay, our claim is that the different types of vehicles have the same mean amount of greenhouse gas emissions. Okay, we have 3 types. So that means mu sub 1 equals mu sub 2 and equaling to mu sub 3. Mu sub 1 would be for type A, mu sub 2 would be for type B, and mu sub 3 would be for type C. Step number 2 is the opposite of the original claim. We'll have to write the opposite in word form, meaning at least one of the means is different. Okay. Again, not all 3 of them have to be different. You just want at least one of them to be different. Now, step number 3 is the null and the alternative hypothesis. Well, that's easy because the null has equal signs in it. So mu sub 1 equals mu sub 2 equals mu sub 3. That will be the claim. And of course, at least one of the means is different. That will be your alternative hypothesis. At least one of the means is different. All right, step number 4 is our level of significance. Let's see what that level of significance is. 0.025. That's our level of significance, 0.025. And now, step number 5, we need to do our test statistic. This is where we use our technology to find out what our test statistic is. I'm going to get this from Statistic. Okay. And for those of you who are already taking my class, you should already have Statistic. And you can sign up for Statistic. Okay. And it's an easy sign up. One of the videos that I created shows you how to sign up for Statistic. Okay. So you don't have to worry about doing any downloading here. All right. So let's go to Statistic. Okay. So this is what Statistic looks like. I've already signed in for Statistic. Okay. Now notice in this case here, this is clear. I do have the sample editor, and I do want that there because I'm going to enter type A in column 1 and type B in column 2 and type C in column 3. Okay. So take a good look at your handout, for example 5 for your notes, and follow along with me. In type A, I'm going to enter these numbers, 7.2, and then 8.1, 7.5, 8.1, 6.9, 8.3, 7.2, 8.3, 8.6, and finally 8.3. Okay. And I'm getting it from this handout right here. And in column 2 will be type B. So I'm clicking on the cell in column 2 and type in 8.5, 8.6, 7.1, 7.7, 7.1, 8.2, 8.3, and 8.2. And then I'm going to put the click on column 3, click on the first cell in column 3, and enter those values for type C, which is in this case 7.5, 8.5, 7.2, 7.7, 8.4, 6.8, 8.4, 7.4, and 8.3. Okay. So what's on the handout for example 5 is the same as what you see here in Statistic. Okay. Now, here's how I do the analysis of variance. On the top row where the blue ribbon is at, click on Analysis. And the one we want to select is One-Way Analysis of Variance, because that's what we're doing in this section of One-Way Analysis of Variance. Click on that. Okay. Now the significance level, you're told to use a 0.025 level of significance. So we need to change this. They give the 0.05 level of significance as a default, but we need to change that to 0.025. And then we want to select the columns to include in the analysis. Here I'm going to select column 1, column 2, and column 3, because that's where the data is in. Type A is in column 1, type B is in column 2, and type C is in column 3. And then I click on the green button that says Evaluate. And these are the results that you see right here. Okay. Those are the results that you see. Okay. And I've also printed this out on as a hard copy. So let me go ahead and go back to here and show you that output. Here it is. So do not worry about this top part right here. Let's look at the bottom part right here, where you have the test statistic, which is your F, and that's this number, 0.15991. And if I want to round this off to 2 decimal places, that would be 0.16. So your F test statistic from Statistic is 0.16. And then step number 6 is going to be the p-value. Now, say we can get that from Statistic as well. So from Statistic, your p-value is equal to, now I'll go back here. So you can see here what your test statistic is. And this down here is your p-value, 0.85312. And I've also had it here. Here's your p-value, 0.85312. Let's say the 2 decimal places, that would be 0.85. Okay, so that's your test statistic. Now, step number 7 is our decision rule, and that's this. We're comparing the p-value with our level of significance. So if the p-value is less than or equal to alpha, reject the null hypothesis. So the p-value in this case was 0.85. My alpha level was 0.025. Well, you can see here, this is that 0.85, which is our p-value. That is greater than our level of significance of 0.025. That means we need to fail to reject the null hypothesis. Fail to reject the null hypothesis. And then step number 8, if we fail to reject the null hypothesis and the claim was that null hypothesis, that means we do not have sufficient evidence to reject the claim. So our conclusion is there is not sufficient evidence to warrant rejection of the claim that the different type of vehicle have the same mean amount of greenhouse gas emissions. Okay. And then I think they asked the question, based on the results, does the type of vehicle appear to affect the amount of greenhouse gas emissions? It does not. So here the type of vehicle does not does not appear to affect does not appear to affect the amount of greenhouse gas emissions for these three types. Okay. So that's the other part of that question that they're asking. Okay, let me quickly show you how to type in or enter this table in the TI 83 or 84 plus calculator, which I have here. Okay, in this case here, I'm gonna press the stat key. I'm putting in new data, so I'm gonna select number 1 for edit. Let's clear out all the stuff that I have here. Like in L1, I need to use the up arrow key to highlight it, then press clear and enter. L2, I'll do the same thing. Use the up arrow key to highlight L2, press clear, and then enter. All right, type A will go into L2. Type A goes into L1. Type B goes into L2. Type C goes into L3. A, B, and then C. So in L1, I'll put these type A values here, 7.2, and enter. 8.1, enter. 7.5, enter. 8.1, enter. Oops, let's delete that out. Now enter. 6.9, enter. 8.3, enter. 7.2, enter. 8.3, enter. Let me go back up. I have 72. This should be 7.2. I'm just trying to make sure that I have everything correct. Let's see, 8.3, I have 8.6 and then 8.3. Press enter after the last number. Right arrow over to type B. Type in 8.5. Well, in L2, you'll type in the type B values. 8.5 and then enter. 8.6, enter. 7.1, enter. 7.7, enter. 7.1, and then enter. 8.2, enter. 8.3, enter. And 8.2, enter. And then use your right arrow key to go to L3. L3 will be type C. 7.5 and enter. 8.5, enter. 7.2, enter. 7.7, enter. 8.4, enter. 6.8, enter. 8.4, enter. 7.4, enter. 8.3, and enter. Okay, so those are all my values here. Type A is in L1, type B is in L2, type C is in L3. Next, I'm going to press the stat key. Use my right arrow key to go over to the test menu. Now you can do this. You can use your down arrow key or you can use your up arrow key. I'm going to use my up arrow key because the very last test is right here, ANOVA. I press the up arrow key because I can get to the ANOVA easy. So ANOVA is the one we select and press enter. Now we need to retrieve list 1, list 2, and list 3, L1, L2, and L3. To do that, we have to press second and number 1. Second and number 1 for L1. They'll be separated by a comma, and the comma is above the number 7 key. Press that. For list 2, second, number 2. Second, number 2 for L2. That's going to be separated by another comma, which is above number 7. and then L3, second and number 3, close parentheses. And then finally, press enter. Notice F test statistic, which is the capital letter F. If I was to round that off to 2 decimal places, that would be 0.16, which is exactly what I have here, 0.16. The p-value you see there is 0.85, rounded to 2 decimal places. Okay. And there's also more stuff right here if you want to look at it. It's not going to be relevant here for this course, because we're just only dealing with just the output. Okay. And not the manual paper and pencil calculations that are done. Okay. But in this case here, your p-value is greater than your level of significance, 0.025. That means you still fail to reject the null hypothesis and conclude that there's not sufficient evidence to warrant rejection of the claim that the different type of vehicle have the same mean amount of greenhouse gas emissions. Okay, so the type of vehicle does not appear to affect the amount of greenhouse gas emissions for these 3 types. Okay, so that's how you use StatDisk and the TI-83 or 84 plus calculator to do ANOVA. All right, so this concludes this video on One-Way ANOVA. Okay, feel free to get some practice over this, and do email me if you have any questions about what's presented in this video and what's in the homework for analysis of variance One-Way ANOVA.